Two?
Math problems number 132.
Math problems number 132. Sorry, just have to zoom out just a little bit. Okay, so we're working on a really tough problem.
Yeah.
And we're kind of stuck.
Yeah.
So hopefully in our movie we can get ourselves unstuck, all right? At the end of week 3, our baseball team's record is 5 wins and 3 losses. 7 losses. 5 wins and 7 losses. Right?
Yeah.
Each week after that, we win 3 games and lose 1. At the end of what week will we have twice as many wins as losses? Okay?
Yeah.
All right. So we made a chart to get started here. We knew in week 3 we had 5 wins and 7 losses. How many did we have in week 4 of each kind?
They were equal.
How? How did we figure that out?
Because 5 plus 3 is 8 and 7 plus 1 is 8.
Okay, great. And then at the end of week 5, how many wins and losses did we have?
Well, then we had 11 wins and 9 losses.
And how do you figure that out?
Because 8 plus 3 is 11 and 8 plus 1 is 9.
Okay, and then at the end of week 6, let's just do that. We didn't do that on our prior chart, but let's do that now. How many wins and losses are we going to have?
We're going to have 14 and 10.
14 and 10. Okay, awesome. And that'll be, what will X be?
X will be 3 for that.
Okay, X will be 3. So we have a pattern for the wins, for example.
Yeah, we're going up by 3.
5, 8, 11, and 14. And this happens when X equals 0, 1, 2, and then 3. Okay, and we're trying to find this pattern here in terms of X. Okay?
Yep.
All right, and so give me a guess. Give me some of your guesses for this in terms of X.
Well, we know that X plus 5 works for 0, but it doesn't work for the others.
Okay, X plus 5 was a good guess because when X equals 0, we got 5.
Yeah.
But when X equals 1,
We get 6.
we got 6, not 8.
We start at 5 though.
Right, and what about, just for this one, what about when X equals 2? What do we get?
We get 7.
So this went 5, 6, 7, and then for X equals 3,
It'll be 8.
it'll be 8. So this went forward by 1 every time. At least it started at the right place, though.
Yeah.
Okay, but it went forward by 1 every time. Okay, so what's another guess?
Well, maybe we could multiply something.
Okay, yeah, let's multiply something.
But it won't work for 0.
Okay, well, what do you want to multiply?
Well, if you multiplied by 5 every time.
Multiply by 5 every time?
Well, it'll go 0, then 5. So, but you need it to differ by 3. So you must multiply by 3.
Okay, what do I get when I multiply this by 3?
You get 3x plus 15.
15, and that's going to go, that does go forward by 3, but unfortunately it starts at 15. When X equals 0, I get 15. When X equals 1, I get what?
You get 18.
18. When X equals 2, what do I get?
21.
When X equals 3, what do I get?
24.
24. Okay, so what's the problem with this one? It goes forward by 3, which is awesome.
You started at 5, so you started at 15.
Yeah.
So you need to divide.
How do I make this start at... Do you notice any relationship, by the way, between 5, 15, 8, 18, 11, 21, 14, 24?
Well, 5 times 3 is 15.
That's true.
All the last digits are the same.
All the last digits are the same. Huh, what does that mean?
That means all of them are multiples of 3.
Here they are, yeah. But how do these numbers relate to this number?
Well, though they don't.
5, 15, 8, 18, 11, 21. How do I get from 11 to 21?
Oh well, you had 10.
You had 10, so this is 10 too high.
So you need to add 5 to them.
To what?
You need to subtract 10 from that, so you need to, it's 3x plus 5.
Oh, let's try. At 0, where am I?
It's 3x plus 5, that's 5.
At 1, where am I?
3 plus 5 is 8.
At 2, where am I?
6 plus 5 is 11.
3, where am I?
You're at 14.
Figured it out. So we start at 5, and we go forward by 3.
Yeah.
Yeah. All right. We got unstuck, and now we'll finish the rest of the problem later today. Okay.
Yeah.
All right, but at least we got unstuck, which is awesome.